So, I know there's a lot of equipment here. Again, my name is John, GA Fleet Tech Services. So, there's a lot of equipment. If you need me to stop and you have any questions to repeat it, or if I'm mumbling, please stop me and I'm more than happy to explain. So, today we are going to be talking about CO2 heat pumps. So, on this site you have 3 air source CO2 heat pumps, which means we're taking the cold air from outside or ambient air temperature at that time. We're putting it through a refrigerant, we're compressing it, and we're creating heat. So from those units outside, each one is 180 degrees coming into these heat exchangers. From these heat exchangers, we're going to be pulling cold domestic water. We're going to be outputting 170 degrees to your tanks. So we're 10-degree delta is what we're getting from there and what we're putting into the tanks. All these tanks that you see behind me and behind you guys are in series, meaning we're going to be feeding domestic hot water to this tank right here, closest to the mixing valve. Okay? So if I pull 180 degrees from my CO2 heat pumps, 170 to the heat exchangers, there's 170 degrees in this line right here. 170 degrees is going to be going into this tank through what's called an injection tee. You see that there's 2 lines coming across the top. So the injection tee is going to be forcing water into this tank. Now, let's pretend building's not using any hot water, we're in what we call a recharge. So in a recharge situation, 170 degrees coming into this tank, it's going to keep filling this tank all the way down. It's going to come up and go into the next one. So this is a series circuit. They're all in line with each other. So we're going to keep charging these tanks all the way down. All right? Now, on each one of these tanks, you're going to see sensors. Sensors are going to correlate with how many units we're going to kick on. And I will show you the temperature set points. If we're getting a large demand, usually peak hours, morning and evening, when everyone's getting up for work and when everyone's getting home from work, we're going to kick on X amount of units so that we can maintain the building and we give them the hot water that they need. But we also want it to be efficient. So we don't want all off, all on, right? It's not efficient, we're going to get big electric bills. So these sensors are going to come in, they're called steps. So we're going to have BT1 over there, BT2. The reason why I'm telling you these things is to explain on the screen later on in the video. So this is BT2, it's going to be a read-only. So you're going to be able to look at the screen, tap the screen, and it's going to tell you, all right, my tank's at 160, 165 degrees. Those steps now kick in at specific set points that I make to the unit. So this is going to be around 127 degrees, which means 2 units are going to be running. If this tank temperature falls below 127, so let's just say 120, 122, we're going to kick on a second unit. The third unit kicks on when this tank gets too cold. So this is going to be around 117 degrees, what we call 5-degree deadband. So it's going to drop to 112 in order for another heat pump to kick on. So when all these tanks are cold, you're going to have all the 3 heat pumps on. Okay? So we're going to charge 170. Typically, you're going to be around 165, 170 into these tanks until we get to these 3 over here. We're going to be around 160 in here, 150 in this storage tank, to 160. There's going to be like a cake over here. 160, 150, and then this is the real big cake where we have 140, 130, and this is going to shut off about 85 degrees down here. Okay. The reason being is when we're feeding into that tank the hot water, we're pulling off this tank from the cold water into our skids. So we're feeding over there, pulling from here. Very important that none of these valves are closed. So when you close these valves, you're not only stopping flow to these, you're also stopping domestic hot water flow out to your building.
Okay, so it should never be off.
It should never be off.
Okay.
So one thing that I would recommend taking and just having in building stock is maybe 1 or 2 of these T&P valves. You know, sometimes people come up here for whatever reason, they open this. Now T&P stands for temperature and pressure relief. So it's 210 degrees Fahrenheit it's supposed to blow off and 150 PSI. Okay? So usually that'll come in, it's to save the equipment, right? You don't want to make a pressurized, you're going to make a pressure cooker up here, that's not good. Now, is that ever going to happen in this situation? No, because there's so many safeties in. So I'm not too concerned about overpressurizing and overheating. I'm more concerned of somebody thinking, oh, this is a place to get water, I got to wash and mop the floor. I got to pop this to get some water on the floor, and it gets stuck open. Has it happened before? It has. So it's just something I would recommend, just 1, 2, just in case somebody does do it accidentally, and you need to close it back up, reseal it, so that you can then isolate the tank, make the change, and then you're back up in
Where
service.
do we get that extra piece from?
So I can place an order for it and have it come
Okay.
to the building, that's fine. Or if you want to source it yourself, any plumbing hardware supply depot usually gets that. So if you'd like, I could definitely get that in for stock. Okay, so in series, does that make sense? Putting hot water into there, pulling from here.
Yeah.
Now that's on a recharge. Now when people are now using the showers, domestic cold water goes back the normal way, like an electric hot water tank. Cold water comes into here, it pushes through all the tanks and pushes hot water to the mixing valve over there. So now we can just turn around again, and that's where this line comes in. So this branch off the T comes down, goes through here, and goes into the hot side of our mixing valve. Now this is our digital mixing valve, okay? Your set point is 120 degrees. Okay? We're at 118 degrees right now. So its job is to modulate through this little valve back here, and it's sending in a voltage. It's just saying, okay, I'm seeing some sinks are being used, some stuff like that. I'm going to open it up more, I'm going to close it. The high temperature alarm for this is 135 degrees. So at 15 degrees over. I can definitely change it if the building finds, but usually our standard is 15 degrees over. It's going to kick in for high temperature alarm. That's if BMS wants to kick in and see, look at this if you have a building monitoring system or anything like that. So it goes to building engineers, so they can look at it. So it's 120 degrees is going to be our base set point on here. We have the cold water line coming in, just like any standard mixing valve. We have our hot, we have our cold, it's going to blend, and then it goes out to the building. And that's where you get 120 degrees.
Okay, when they say 120 degrees, is it gonna read in the water temperature in the apartment as 120?
It's reading it local to here. So when they were just testing it, floor below, we were like 116. So I can increase it if the building wants to 125. We do have some buildings that do 125.
Per HPD guidelines, yeah, we have to be at 120, 125 and higher.
Okay,
120 and higher, yeah. it
Yeah,
has
so
to
that's
be-
easy enough. I can make the change.
Okay.
Yeah.
Okay.
So 120, anything greater than that though, then I would just need a written email and I can make the change.
Okay.
Usually like cooks, and like if we have kitchens and stuff like that, they want 140 and stuff. But yeah, 125 is not a problem. I do
Yeah.
have a couple other projects
Okay.
that have 125.
Thank
so not
you.
a big deal. Yeah.
Okay.
So then this guy comes in. So this guy right here, this is going to be maintaining our return loop. So return loop is you open up the faucet, it takes forever for hot water to get there. This prevents that from happening. So what that is it's a small electric heater. So there's a flow meter in here. So this line right here is, say, coming from your return loop. Picture the building like a giant radiator, right? You have all these lines and all these pipes sitting there. When they sit there, nobody's using water, it gets cold. And then you got to sit there with the sink open forever. And then finally it heats up. Well, that's not the case in this building. What we're doing is we have a pump on that wall, which I'll show you in a little bit. It's pumping water through here. We're looking at the flow, and then we have 3 electric elements in here. Depending on how great the flow is and how cold the water is, it's going to fire the X amount of units, the X amount of elements. Then that hot water is going to come out, mix into here, and then go out. So it actually splits the 2 different sides. So we have domestic hot water return coming into your hot water side here. And then it's also split off the pump to feed your cold water line. Now I know there's a bunch of lines and all of them kind of blend together, especially with the white backdrop on the wall. But the pump that's on the wall comes in and it splits between these 2. Comes down, one line comes into here, the other side goes into your cold water section. Yep. So, and as far as temperature, it's, the code for return water is typically 110 to 115. I personally like setting it to 120. Because I set this to 120 because the aquastat on the wall, which is controlling the pump, I'll show you guys in a little bit, is usually about 115. So that'll turn on and off. I give it about a 5-degree delta, so difference in temperature. So right now, I set this up in a diag menu so that when you come up here, it's going to stay like this unless someone cycles power. It's showing your outlet, your inlet, and your flow. And I'll explain what those look like. So right now, this is your set point, 120. Your outlet with an O is 122. Your inlet is also 122, and your flow is 1.3 GPM. So that's it, F, I, and O. Okay? Flow, inlet, outlet, and then you got your set point. So this is very easy to get out of the menu. You can press up or down, it locks out of the menu, and then you can increase, decrease set point from there. Okay? So I will change the set point at the end of the video, but now I want to go into the schedule a little bit. So do the tanks, return, all that stuff make sense?
Yes.
Right? It's just all digital.
Yeah.